Oh no, I need the help! Help me, Iron Man! It's a Mario! What are you doing?
Oh, hi, Mr. Tro. How's it going?
It's going all right. Were you playing a video game or something?
No, I was preparing to set up this lab. All right, so today we're going to react magnesium, which is a shiny metal.
Now that's the metal strip in your hand, not the ring around your finger.
Sorry.
Got it.
Yes.
Okay, we've seen that before. All right.
Okay. And so it's going to undergo a reaction with hydrochloric acid.
Clear, colorless liquid. We actually saw that in one of our previous labs.
That's right. It reacts with metals.
Okay.
So the reaction is going to produce a compound, and we're going to determine the empirical formula of the compound by weight. So we're going to weigh the magnesium at the beginning, and then we're going to observe the reaction, and then the product is going to contain magnesium and chlorine.
Okay.
And by weighing this at several points during the reaction, we'll be able to subtract, get masses, and determine moles and empirical formula.
All right, let's get some data then, shall we?
Okay.
Okay, we're here at our analytical balance. It's set to 0, so we're ready to go. We're going to put our dry, empty flask. That's the noise that this analytical balance makes when it's weighing something. 41.399 grams. So we want to record that in our data table. That's the mass of our empty flask, 41.399 grams. So now let's weigh our magnesium. You might be thinking that's not magnesium, that's just a plastic dish. We call it a weigh boat. What we're going to do though is we're going to zero that out. Tell the scale not to regard that as a mass, because we want to systematically add magnesium pieces. Now the lab says we should have about 0.2 grams. Here we go.
But Mr. Tro, that's not exactly 0.200.
It's okay, the lab says about 0.2. What's important is we know the exact mass, not that it's exactly 0.200.
Oh.
So 0.204 grams is the mass of our magnesium. Okay. All right, looks like we moved locations here. What's this thing called?
This is the fume hood, right? This is so that anytime there's a reaction that produces a lot of fumes, it gets sucked up into the vents and it shoots out to the top of the roof.
We actually saw this earlier in the year when we did the alkali metal demonstration. Remember when you got a piece of it on your hand and it burned you a little bit?
Oh yeah, I remember that.
That was pretty awesome.
Yeah, that was fun.
Yeah. Wow, what colors are those flames, Mr. Park?
They look violet.
Violet. The other flames were violet. Oh, hello! Scars for life. Okay, so we got, oh, looks like a hot plate.
This is the hot plate. And here's our flask. So we want the magnesium to react with the hydrochloric acid. So the reaction is going to take place. It's going to produce hydrogen gas, which is why we're in the fume hood, because we want the gas to leave. We don't want it to build up in the lab. So I'm going to start by adding the hydrochloric acid.
Now the lab calls for about 6 milliliters.
Right. 6, 7, 5, around 6 is fine.
Nothing's happening.
It's because it's not reacting with anything yet.
Okay.
Okay, so I'm going to put that on the hot plate, and I'm going to add the metal pieces.
Be careful.
The reaction should be pretty evident almost immediately.
Yeah, definitely see it bubbling. Looks like the flask is getting a little cloudy, some sort of liquid vapor. Ooh, it's warm.
Well, it's on a hot plate.
True. It's kind of hard to see, but you can see a little bit of vapor coming out the top, so there's definitely gases being produced. They're being sucked up, and it's bubbling away.
Alright, so the magnesium's all reacted, and that means it's all dissolved. So what we're going to do is we're going to let this sit and let the water evaporate out, because the hydrochloric acid was a solution. It contained HCl and water.
Okay.
And the water we need to leave because we don't want the weight of water included. So once this completely dries out and all the water leaves, what's going to be left is the magnesium compound with chlorine.
So how do we know that it's going to be a magnesium chloride compound?
Because the chlorine reacted and it's going to bond with the magnesium, even though right now they're dissolved and you don't see them. But once the water leaves, you'll be able to see the compound.
Okay, so the magnesium ion and the chloride ion, they're dissolved right now, so they're not actually bonded?
Not yet. They won't bond until the water leaves.
Okay, so they prefer to be in the water over bonded, but once we let the water go away, they'll be closer together, they'll form their bond, and they'll form hopefully some sort of an ionic compound.
That's the plan.
Okay, so we're gonna have to just let this heat for a while so that the water can vaporize away. So we'll check back on that in a few minutes. Mr. Parker, I noticed there's a little bit of discoloration. It used to be a little clearer, but now it's...
Yeah, that yellow color is from the chlorine.
Oh. I wonder if the solid will be yellow. If chloride makes the solution yellow, maybe the solid will be yellow too.
Yeah, there'll be some traces of yellow in it.
Huh. So just gonna keep letting that boil. Are changing here.
Well, the solution is reducing, so there's less total volume of liquid. Most of the water's evaporated out. Pretty soon, we're going to start to see the solid dry up.
So right now, all the magnesium and chloride ions are still dissolved in the little bit of liquid that's left, huh?
Right.
Park. See some changes.
Starting to see some solids. The bubbles are fewer and far between. Let's turn this down.
Yeah, I see a white solid.
Still some moisture left in there though, so we got a little bit to go. What we're going to want to do is we're going to want to gently hold this over a burner, and what that's going to do is evaporate the rest of the liquid that's on the walls here that's hard to evaporate because it's not as close to the heat source.
You said that we would take this over to a Bunsen burner to dry off the sides. Wouldn't they just dry if we kept it on the plate?
You know what? In a normal lab environment, we would be drying this over a hot plate or a Bunsen burner, but that's because in a normal period we don't have that much time. with the magic of time-lapse video filming, we can actually take this nice and slow, and we'll get better results this way if we just let it sit on the hot plate. Because that's actually a gentler way of heating it, and we should get better results.
Okay, so we'll let this go for a few more minutes, and then we'll check it. Hey, Mr. Park, I think it's done.
Yeah, see, all the moisture's gone, and you can tell it's gone because not only is it dry on the bottom, but the flask itself is dry by the top. Because that's the last place where the moisture leaves. So if the moisture's gone, then we know it's done.
All right, well,
let's go away.
Let's go away. After you. Hello, Miss Fiore. Now, there was a scale right over there by the fume hood, Mr. Park. Why are we going all the way back over here?
Well, you have to use the same scale because it's calibrated exactly the same way. If we use a different scale, the internal calibration might cause this to appear a different weight than it actually is. It's just like if you weigh yourself, if you're on a diet, you would use the same scale.
Diet sounds terrible. Okay. So 42.290 grams. Well, we only started with 0.2 grams of magnesium.
Well,
that's a huge mass.
That includes the mass of the flask.
Oh.
And that's why we weighed the flask empty
silly.
at the beginning, so that we can subtract.
Great. So let's take a look here at what Miss Fiore has been writing down. Oh. For all you at home, in case you missed it in the video, those are the values we should have in our data table. That's not too much. Okay. Are we going to make the Are we going to make the sound effect ourselves?
I don't know how you're going to edit
That'd be kind of funny. Okay, we're here at our. We're back. You can put away your video game, Mr. Park.
I'm not playing video games. All right, I'm texting the babysitter.
Oh, okay. That's important too, I guess.
Okay. So we are now going to react.
Aren't you a little old for a babysitter? So stupid. All right. Okay, so we're I think we're done, right?
I think we're done.
All right, I'll clean up here. Ow! Gee! Woo!
Are you okay?
It's hot. The hot plate's hot. Go figure. Ouch.